Okay, hi everyone. Good evening. I hope you are all doing great. Sorry about the audio issue yesterday. It's good to have you back. And well done, everyone. To those who tried out yesterday quiz, that was a good one. And at this point, it doesn't take forever to be able to try what you've learned. As you keep learning, you keep getting better. And like I said, I expect everyone to have a material where they write their notes. All right, you need to write your notes. Is always very important because there are things we are saying that might not be directly in the material, but they will be useful in the background. You know, so I will always recommend as much as you can to have your own notes. All right. So we'll continue from where we stopped yesterday, and today we are going to possibly try a real life project together, just to guide us through the possible things that we can do as we move on, or possible also give it to you and maybe or you try it over the weekend. Then on Monday we come and check it together. Like some people say we should do revision. So that would be like our revision. But it's always good to revise what you've tried. All right, that's my personal style of evaluating what you're doing. So it's always good to revise what you've tried, so that when you are saying something, it will stay with you because you've tried it before. It's not like the first time you are hearing it. Alright. It's not like the first time that you are hearing it. So today we're just going to look at few other things to take note on our models. Yesterday, as the last time I was on, we were trying to build a random forest classifier. After we have gotten our results, of course, it's showing like an 100% thing, which is like I mentioned, is not going to be something you completely rely on, because that is not going to be a real case, right? You won't completely say that you have 100%, as it were. Okay. So one of the other things you can get from your random forest classifier is what we call feature importance. Now, what does this feature importance is? I need to rerun my code again because I had to shut down a number of things. So I'm just going to run them again. See the state that we are in. Now, what is feature importance? Just like the word says, so based on the model that it has built, it's going to tell me the features that are important from the data. Of course, if you look at this tax, I think we only have like 4 features or there about two. If you look at this data that we worked on, what's happening? Why is everything looking blank? Okay. Yeah, so you can see here we have 4 features, right? So, and of course, when we are building our model, we still use all of them as our X. So it's trying to show us here how important those features are. So you can see that based on the model that it has built, this petal length CM seems to be more important. It's over 40% of importance, which is also going to help you know how your model has learned well, or the feature that it has paid attention to. Excuse me. Followed by petal width CM, which is almost about 40%. This one is about almost 50. Looking at the range that's available, or is 0.45, about 45%. Sepal width, you can see this is less than 10%. Sepal length has about 10%, right? This shows us how the model does, or how important the model is based on what we are doing. Now, another thing we tried here was another data set. Like I said, the reason why we are using all these already made data sets is for us to be able to really use the method that we are trying, right? So that we don't have to do all the cleaning and all of that on real data. But of course, it's the same thing even if we pick up real data, all right, for whatever it is that we are doing. So we import pandas, numpy. From sklearn metrics, we import classification reports, confusion metrics. From sklearn dataset, we are using the load breast cancer, and the model we want to build is the SVM. What is SVM? Support vector machine. So if we run this part, the model has been. So the next thing is to call the dataset we want to use into the cancer. So df.def fit, this is to create a data frame whereby it picks from the data, and the column should be the column names, features names that is available in the cancer data set. Why the df underscore target should be the target that is available in this data set. The column name should be cancer. Now we want to check the feature variables, the information about the features. Then we want to check the feature edge just to get some insight from the data. So from here we can see that we have about 569 records. If we look around board, you can see that there are no missing data. Why? Because apparently most of these things are there. Then if you look at the other part, you will see features data frame like what we have here. The second thing we are trying is the .ed. The first one we try is the .info, just to check information, the column name, the number of records you have there. If there are none and the data type, that's for .info. But for but for .ed, all right, I can always copy this out so that we can see it clearly. That print is the one making it look scatty like this. So we can easily just do the df fit .ed alone so that we can easily see what we have. Can you see this? So from here now you can see it has 30 column, which is huge, right? It has so much information. And of course, the last thing you are going to be seeing, the most thing that you're going to be seeing here is the target. So from here now you can see that the only features that we have here, there are 30 columns, all right, and we have how many of this information. So we can do .shape, the fit .shape. So from here now we can see we have 569 records and 30 column, which is also good. So the next thing we can do is to split our data. All right, we are splitting our data into the 4 portion like we've learned before. So we are having our x train, x test, y train, y test. All right, train test split. We have default underscore fit and pd.travel df. So the question is, what does this guy mean? All right, so you can always read, like I mentioned, you can always read about them. But one of the key things this is doing at this point is that it's trying to combine whatever it is that we have in our data df or that's target to, like it means right numbers, right? That's what it's doing here. So that's what it's doing here. Then the test size says is what? 30%. Random state is 101. So what that means is that if you are testing with 30%, then we are training with 70% of the entire data. Random state is 101 for this particular case. So if we run this now, so it has split into these 4 portions. We can check them out. So if we check S train, we have the 70% of the data. If we do .shape, so that's the 70% of the data. If we check our X test .shape, is going to tell you the number of data is testing with. Then your Y train is also going to be the Y train is still going to be the same thing as that. It's going to be the top 70% of the data. Then if you move on from here, if you check the Y test, it's going to also show you the 30% you are testing with. So you can see that. So the next thing we did here was to call the model we want to use. Call the model, initialize the model, anyone. It's still the same thing we are saying. So initializing the model as an object. Then from here, the next thing we are doing here is to what? Is to build the model using .fit. Build the model using .fit method. Then the next part is to what? Is to predict the model. Don't forget, these are the steps we always have. Predict the model using the test data. It's always good for you to make all of these notes. While the final one now is evaluate the model using a method called classification reports. So most time I will recommend that you try this classification report because there are many information that it will tell you, inside the data. There are many information it's going to tell you inside the data. So if you look at this, if we run this guy, like look at what we have here. So this is a result of what we have. So you can see 0 1. 0 1 simply means the class. So 0 will mean you didn't have breast cancer, for example. 1 will mean it has breast cancer. So this precision recall and F1 score, don't forget we have learned about the peculiarity for them here. Precision talks about quality of positive prediction. Recall, we talk about it. F1 score, we spoke about it. So all of these things are also going to be handy in your interpretation. They're also going to be handy in your interpretation. So if you look at this now, you can see that precision is focusing on the quality of the positive predictions. All right, what really happened exactly in the data. All right, what really happened in the exact data. So it represents overall correctness. That is for accuracy, but for precision, how many predicted values are actually correct. High precision means fewer false positives, useful in tasks like spam detection or fraud detection. We also have recall. We talked about the sensitivity, the true positive rate. Recall measures how many actual positive samples are correctly identified. While for precision, it's talking about how many predicted positives are actually positive. While the F1 score is finding the harmonic mean of the precision and the recall. So if you look at what we have here, so if you look at this result, like we have mentioned, precision is more talking about what you predicted, while your recall talks about the sensitivity of the actual value that is there. I'm trying to go to the result again and give you some, some ways you can interpret it. So what this means for 0 now, for example, is saying that 95% was actually correctly predicted as no cancer. 1 simply means 91% was actually correctly predicted as breast cancer. While recall shows the sensitivity, 85% is actually saying that it is the real value there is no breast cancer. While 97% is showing that what this is actually the positive value there is that there is breast cancer. Now this calculation, forget that if you get F1 score of your no breast cancer or breast cancer, it's a calculation of these two guys. You are finding the mean of these two guys to get this. Same thing for our this to get this value. Why the accuracy, which is the correctness overall of the two cases that we have. So this model shows that it has 92% accuracy, which shows 92% of how accurate our model is, which is a good number. It's not bad. All right, but like I said, it depends on what you're trying to do. It depends on the approach you're trying to do. But at this case, it is more of an accuracy thing that you are looking at here. But of course, you can try to say it is the F1 score you want to pay attention to. You might say it is the real score you want to pay attention to. Is the F1, but of course, you can see from the predicted here that there are more likelihood that the predicted value works more for where there is no cancer, right? But then if you also go and check, the targets, if you check for example, if you come here where we are splitting to our target here, for example, I want to show you something. Okay, I can even show you that from our white train or white test. Okay, because of the version that it is, we are not able to get, because it's no longer a data frame kind of, we're not able to get that. But I wanted to show you the column name and try to get a value count of all the classes. So let me see if I'm able to get that from this splitting. Just wanted to show you something about imbalanced classes. Okay, let me use this df target. df, it's like a column. Or let me see what is going to display. Okay, we have cancer here. So I can do df this, and I pass cancer, which is the name of the column here, and I do value count, because you need to understand when they are. Okay, look at this now. So you can see that this is an example of imbalanced classes. Let me normalize it to be true so that I can get the percentage. All right, so what this tells us is, for my target now, for example, we have about 63% to be that there is breast cancer, while 37% shows that there are no breast cancer. Of course, it's not a very heavy imbalanced class, but it also shows a very clear picture that there is a particular percentage that seems to be more than the other. And if we don't undo imbalanced classes on it, there is a high likelihood that the results will also follow this pattern. That means we have more prediction for breast cancer over no breast cancer. So if we go again and check these results that we are getting here, look at the result, you can see that. But then you can see you can see that from this now, we are not really seeing the effect of the fact that one was more than the other in this result now. You can, or let me look at it again. Oh, you can see the result of the fact that it's predicting more of 1 over 0. All right, at some point, if you look at this result now, so that there is more of 97 and 85. These differences is because of the actual data that you are having, the kind of data that you are storing in the actual data set you are working with. You can see the effect of those two guys here. So that's possible because it has learned that there is more of cancer than no cancer. All right, but in real time, one of the things we can do really at this stage is to undo imbalance classes. But before we talk about that, let's talk about the issue of overfitting, because we have to know, are we overfitting or not? Okay, is this 92%, is it overfitting or not? Is it just learning from the pattern, or is it working across board? These are possible things you want to try out. These are possible things you want to check out first. All right, these are possible things you want to try out as much as you can. These are possible things you want to try as much as you can. Okay, so accuracy is 92%. 0 and 1 here talks about 0 is no cancer, 1 is cancer. So with this now, we can see that the result tends towards something here. All right, the result tends towards something here. So if you look at this now, from sklearn model selection, import grid search. Now, what is the purpose of grid search CV? It is one, we use it for cross validation. And what is the beauty of cross validation? I've told you that before. It helps us to prevent overfitting on our model. And one of the things you can do before you even do your cross validation in your data set is grid search. What is this grid search? Because every model that we're trying to run, they have their own parameters. All right, you can see all the parameters. For example, for this SVC now, you can see C, you can see kernel, you can see degree, you can see gamma, you can see coefficient, you can see stringing. Now the question, I don't even know what these things mean. Yes, you don't need to cram them, but every of them has their own, and they have possible values. But for model performance, or for improving model performance, there is a way we can test what should the value be, by not just putting the default value. So there are two ways you can. I've told you about research the other time, and I told you about experimenting. So the grid search helps us to experiment on our data sets. It's not just putting a value. So the goal here is that, for this, for example, for this my decision trio, I want to check out certain parameters before I even build it. You can see here that we have parameter underscore grid. Max depth range is what? 1 to 10. Minimum sample leave range is 1 to 20. within the range, I mean starting in the range of 2. Minimum sample split, it should start from 2 and end at 20, and the number of step is 2. The ketone, I'm saying that it could either be entropy or Gini. What I'm doing here is that I want to use this parameter in my model, but I don't want to be the one to give it an exact value. I want it to I want it to do a Greek search to find the best. Why are we doing Greek search? Please take note of this. Is to be able to find the best parameter, because he has done his own internal building with a data set. He's going to now use this to find the best parameter that I should use on my model. So this also we also improve how our model is going to do. And you can see here that I'm also introducing what CV, which is cross validation. That means I want to be able to do cross validation of my model here. So for example, with this now, that means if I'm passing 5, it's going to do some subset of my data set. It's going to train the model the first time, the second time, the third time, the fourth time, and once that is in, we are fine. Before he even now what gives me my results. All right, before he even gives me my results, let me check the chat. Is there anything I need to address? I say, why is accuracy not the true metrics of the model performance? What will be the true determinant among all these metrics? So it depends on, somebody say my front is small. What determines the number of in a random state? Can we do feature importance on all model? No, we can't do feature importance on all model. Some models don't have that uh, parameter to check, but the light of some of these three models, you can do feature importance on them. Somebody is asking, what is the size of record is considered adequate for model building? The more the data, we can't say exactly, but you know what is small. 10 is small, 20 is small. But the more the data, the more the model does. When you say my front is small, let me see if I can increase that. But this is not really too small. It's about 120 already. Okay, but I've made it bigger. Any other thing? So it's today's class. Yeah. Okay, so let's move on from where we stopped. So some people are already asking, how do we know it's overfitting? Like I said, it's this experiment that will make us know. And one of the easiest ways, you have seen your result at the initial stage with this guy now. All right, we can see our result at the initial stage, 92%. Now, one of the things is because the way we are working at this point, we don't directly have like a text data somewhere in another folder. So most time, that is why we at this stage you need to pay attention to the steps involved. But one of the things you can know if you are overfitting is some of the steps we are taking here. So even whether you want to know whether it's overfitting or not, you first need to have experimented it. You first need to have tried it. All right, you need to try it. All right, so that is one key thing to take note of. From sklearn.model selection, import grid search CV. So if you look at parameter grid here, we are passing these parameters. Now don't forget this grid search. Now we are importing it. The goal of this grid search one is for us to be able to get the accurate parameters for our model. The accurate parameter for our model. Then the estimator here is the tree, which is this model we want to build. The model we want to build is this guy. All right, the parameter grid, you can see them. We want to use maximum depth, minimum sample leave, minimum sample split. Click is going to pick one of these two based on the result. CV means that this CV means that you want to do cross validation, and of course, how many of it? 5. Verbose true means that you want to also avoid overfitting in what you are doing. Then you can see that the grid search dot fit is X train and Y train. So we are printing the best accuracy here, which is the score. And of course, you want to also know each of the parameters, which one is the best for our data set that we are working with here. So if you can see, it's going to take some time. That's why I'm running it again. You say fitting 5 folds for each of the 1,620 candidates, totally 8,100 feet. You can see how much it has split the data. That is learning so much well. All right. So when you do grid, you have to be very sure that you have a good system. Or grid search used to take time. Or grid search takes time. So you have to be sure that you have a good computing system before you go and jump on doing grid search. Else, we will have certain setback, and that is that it's going to take time. So try to have a system that can run this. And of course, that's one of the reasons why we also introduce platforms like Google Code Lab, because at some point from now, you will need some of those cloud platforms to run your code. I think next week I will make sure that I'm running my code on Google Code Lab so that you can also see how some of these things are run. Because you can see it's still fitting and it might take some time because it's trying to get the best parameter based on the data set I have plugged into it. And these are some of the things you should try out, really. These are some of the things you should try out. But of course, they are good, but they take time. That's why you have to show that your system has the memory level is strong enough, to run this kind of code. This is going to take a few times. You can see the kind of thing is running. It's going to run each of these data at least 5 times. Okay. The value beside it are not they are the values it should pick from. All right, it's going to go through each of the, for example, it's trying to train the first time, it pick each of the values that are there. It picks 1, 2, 3, 4, that range, and see based on the models, which of the, so that's why you can see it's also taking time, because it's going to pick from each of those values and test it on the model. That's why you can see that it's going to be doing a lot of things in the background before it works. So we are still waiting for this to load. It will take time, so it depends on your system. So it's still you can see it's still trying to fit. This takes a bit of time, trust me, and you also need to have that time. They are the best ways of handling your data, but of course you can also continue to use the ones that we are plugging just the parameters straight up. But these are things, because they will also improve the way your model does. They will also help you to manage issues of overfitting. Yeah, it might take up to 1 to 2 hours. It depends on the data itself that you are trying to create, put all these guys on. So, yeah. But I mean, I'm not sure this one is supposed to take that much. It's just about 500 and something data. But you can see the number of, grid that we are working with and all of that. Yeah. Yeah, it can even take more than an hour. It can take 2 hours. It depends on your system, depends on. So, which system specialization is best for this training? At least you should be using a Core i from 5 7. If you can get a system that is GPU, it's also a good plus for you. But if it can't, that's why I said there are cloud tools that we can use. As long as you have a good system, you can leverage on the light of Google Code Lab for you to run some of your models. All right, because when you are working, your system GPU might not be enough. Unless data is very small, you might not have issue of underfitting really. Yeah, you might not really have the issue of underfitting. Most time, the core thing, because underfitting simply means that data is not even given on trained data, and that's obviously not an ideal situation, right? So by overfitting is talking about the fact that it's only learning well from trained data and is not doing well on scene or text data. So okay, so it's done now. So here you can see it says fit on the five folds for each of 162 candidates, totally 100. This is the number of times that it has to build the model based on what we have passed. You can see it says the best model, the best accuracy here is what 0.944. All right, and of course we're also trying to get the best parameter based on what it has worked with. You can see that the decision tree classifier work with citron to be entropy, even though we passed both these two. So the best one was entropy. The maximum depth was 4, and the random state was 1, which was like, I think that was what we passed directly here. So those are the three feature in now used to get the result that we have now. All right. So another thing we have here, hyperparameter tuning with grid search, like what we just did now. So another parameter that we can check is C, gamma, or kernel on which of our model. I think it's still on. So this one is doing grid search on our SVC, the one we built the other time here. Yeah, that gave us 92% for this guy. So we can train that again for this one. So grid search parameter parameter grid we fit through variable 3. So grip.fit. So based on this, we are fitting on our data sets those values that it has calculated. So you're expecting it to pass these three guys into the model. So let's see. Yeah, this is a bit faster, so that you can see that some models are faster. So that is why the architecture of a model also goes a long way in how the model performs. Okay. Okay. So here we can check the best parameters and also the best estimator. So you can see the best parameter in this model now is C to be 1, gamma to be 0.001, kernel to be RBF. So the SVC now is taking the C1, gamma to be 0.001, and kernel to be that one. So if you look at this now, so we are saying the grid prediction now, we are using the grid, which is the one we are fitting into. Don't, if you look at this carefully, so this is the gear where we are storing the model that we have trained, right? So if you look at what we have here, so you can see here, that's the grid. So the grid prediction dot predict is on our test. Then the classification report, you can see we're doing our Y tests and our grid predictions. So look at the result we are getting. You can see one, it has improved from 92% to 94%. Can you see that? So apart from that, is handling imbalance issues is also possible going to undo overfitting issues in your model. So you can see that it's the great result now. You can see, so it's also improving the model performance, which is also one key thing that is important. So you can see that we now have 94%, the same model, but different parameters. All right. And that is the beauty of being a machine learning engineer. You must be able to explore the model such that you are able to get better results. And not some people will come and say, that's my one result. No, you have to be able to experiment your model. You have to be, can you see this? This is showing 92%. You can see this is showing 95% and 95% for our 95% for uh no cancer, 91% for that. But you can see how this result has improved And what improved the model? One was cross validation, two, hyperparameter tuning, and our Greek search was what improved this model performance. And that's also one of the things you must be able to do on your model. You must be able to do hyperparameter. Like I say, hyperparameter tuning can always take time, but it's also one of the best that you can think of. And what other way, if you're not experimenting like this, then you can depend on what other researcher has done. Oh, maybe their own value is gamma is 1.111. You have to find like a material where they experimented it and it worked. If you don't want to go through this stress, I've told you two ways of doing your hyperparameter tuning, or doing your hyperparameter tuning, or passing parameters into your model. One is by experimenting like what I just did now, or by research. What are other people saying? What are other researchers saying? That's some of the things you want to look at. Vapors talks about when you should stop, so it's more like an early stop for your model. So that's it's trying to also control the way your model is doing. But like I said, all parameters you can always also read about them. All right. The material is there. The shift tab will also show you some of these things. But most of the things that we're passing now will help you to control overfitting, will help you to manage your results too. So you can see what we did here now. So that's one of the things you might also want to try out. All right. That's one of the things you might also want to try out. Then at some point we can put exact value there. That means I'm leveraging on what a researcher has done before, an expert like myself has done before in some notebooks to just put direct data. Now this time around we are doing something a bit different, and here we are just passing a real data. So if you check through this guy, there is a data set called arts somewhere here. Yeah, arts.csv. So we're going to be using that this time for our model. Okay. So you can see here now we have let me close this part. So if I give you tax, all of these things are the things that will show that you really understand how machine learning works. So if you look at this now, we are loading data here, and we are loading the top 7 records. Then from there, we are dropping our target. Why? Because our target will never be in our features. Please take note of that. Our target is also only supposed to, let me close this. Let me copy this out so that you understand what I'm saying. Let's take it one by one. Because it's always good to separate some of these things. So I'm loading my what's it called now? I'm loading my libraries I want to use. The next thing is to load my data sets. So make sure that the data set you are working with is in the same directory with your notebook. Please make sure that you do that. All right. So make sure that your data set is available in the same directory. Wherever your notebook is, make sure that your data set is also there. That's the easiest way. That's why I place all these things here so that you don't be having issue of directory not found. Whenever you're working, make sure you are in the same directory. Yeah, somebody's asking the code line we used create the glycer. Is it example of pipeline? Yes. If you want to use the terminology, yeah, that can also mean that. Well, the fact that the two are even closer to each other, despite the fact that the values inside them are different from each other, that even makes you trust the result, right? But most of the time, it's always going to be, from what we can see, most of the time, it can either be your recall or it can be your precision. It can even be your accuracy. We're not saying that you should drop off accuracy, but all of them seems to be doing well. Those values are good numbers, right? Those values are good number, which is something we can still as it were, also trust, right? But it depends on the domain, the kind of problem you're trying to solve. Is accuracy going to be the real thing, or is it going to be the precision, or the recall, or even the F1 score? Even for some tasks, they will tell you what you should focus on as your target, as your metrics. All right, but all of them are useful. That's why you're having them in like a table. So they are all very useful, but it depends on what you want to conclude on. Depends on what the team wants to use, right? So let's check the data. So here we have the age, we have the sex, we have the CP, chest PS, all of these guys, and we have our target in the data. All right, in our data. The next thing you can check, do all your data cleaning processes. But of course, for this data, there may not be too much thing. Is there missing data? You can check that. Okay, they are not missing data, Abby. No, 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 no. I'm running a wrong data frame. This should be data. No missing data. Data dot columns. I have all of these columns. I have all these columns. Let me check the shape. Data dot shape. I have about 1,000 plus data, right, and 14 columns. I've told you most of the times in the real data, your target will always, the fact that this one is saying target does not mean your target, which is your label, will always be like the last one. That means for this model now, we have 13 features and we have one target. All right, we have 13 features, which is the one we also call independent variables, and these are dependent variables. So based on all of these ones, we can predict, all right, our targets here. And of course, if we check the data target 2 inside the data, we can see the state of things. We say data and we say target, for example, dot value count. So you can see for people that has art issue 526, people that does not have. If you do normalize here, you have the exact percentage. All right, so about for people who has art issue, they are 51% and 48%. Of course, they are still imbalanced class, but it's not too much. The gaps between them is not too much. For 51 to 48, I think that should be about 3% thereabout. But of course, that also is also something. But for it's not very, very, very high. But the likelihood of 10 turning towards one is high too. All right, that's also high. So it's not something we can completely look away. It's not something we can completely look away. But the fact that we are already handling some of these issues, we can look at them. So for our X, don't forget our X will be all the other feature apart from our targets. Our X, which is our features, will be the other features apart from our targets. While our Y will be only the targets. Please take note of that when you are splitting your data into X and Y. All right. So parameter tuning, accuracy of the model should increase. Target is usually as label values. Yeah. Okay. So take note that our X will be all the features we want to train with. You can also go as far as checking the correlation first to know the features that are actually correlating well. So I can do data dot correlation. I can decide to also draw my heat map. All right. So many things I can check here. You can see that many of them really does not have too much correlation. You can see the targets. This is negative. This does not have correlation. Does not have correlation. This has about 43% correlation. This has no correlation. This has no correlation. This has no correlation. This has about 13% correlation. This has 42%. This does not have any correlation because it's showing negative. Oh, I hope I'm on the right one. Okay, the last one. So you can use that also to know. Because another thing to take note, if a particular feature has a very high correlation to your target, please note that if it has very high correlation to your target, I guess that means that if it's in your model might be overfitting because it's a very important feature that should not possibly be in your model. So most times we pay attention to the features that has not too much correlation or that are negative like this. So it's not a model that we now need to learn from it. But if a particular feature has so much correlation to it, to your targets, that feature might be causing overfitting on your model. So most time we can do feature selection to drop those ones that are too much correlated. All right, too much but for this time we are not doing that. Maybe it does not have too much correlation, so we are just going to possibly look at it or use it like that. All right, so just use it like that at this stage. So the idea whereby we are not dropping any feature. The model we are building at that point is what we call baseline model. So at this point, whereby we are not dropping any feature, we're just throwing all the feature into it to first even see how our model is doing. So most time when you are experimenting, first drop your baseline model. A baseline model is a model that you just do without doing too much tuning, without doing too much cleaning, without doing too much hyperparameter tuning or this or that on your model. You just pick the data after you have cleaned the data and you split it into your X and Y. You got your portions for training and testing. You build your model and you get your results. Yeah, now we didn't even do any scaling. We didn't even do any hyperparameter tuning. This is an example of a baseline model. So if your baseline model is doing well, that means you will not do too much work trying to train the model to get better. And that is always the first way to experiment. All right, that is always the first way to experiment. You need to try, just throw your data into your model straight and see what you get without even doing too much pre-processing on that are needed for your model to perform well. We didn't do scaling, we didn't drop columns, we didn't do anything. We just use all our features like that, and let's check our results. You can see with this, even without doing too much thing, we still have 82% for our accuracy. For our precision, we have 73% for no art condition, 92%. Of course, you should expect that because a particular percentage seems to be doing much well than the other. The record, 91% for no art condition, 77% for art condition. This is a picture of what has been predicted. This is the ultra radar. This is the ultra precision is what you predicted for the correctness of each of these value. This is the correctness for each of these value when in the ultra. The F1 score is the combination of precision and recall to get this result. So accuracy is at 2%. Let's see what else we can do. So of course, your next job is going to be thinking about how can I improve this model? How can I be sure that this model is not overfitting? How can I be sure that the result I'm getting can be better? And one of the things you can do is your Greek search. You can decide to do a Greek search on the model. All right, you can start to do a Greek search on the model, not just using the already exist. This is not a bad result, but the result might be better, can be better. So we are passing in some parameters here we want to do a Greek search on just to see the results. So this sign here shows that your model, that cell is still running. So that's just that you can take notes. Like I told you, that might take some time, but it's always a good way because it has a likelihood of doing well on your model. This asterisk sign here is what I'm talking about. This asterisk sign here shows that this cell, not even the model, any cell they're trying to run, it shows that it's still running because you want to ask, is this still running or not? So that cell also has a way to tell us that this is still running because I didn't ask you to be showing me how it is running. It's just doing that internally and it's going to just give me the best parameter in my results and the best estimator in my results. So the model is still building. Like I said, this might take some time because it's hyperparameter training. It's checking through all the range of what is available in the parameter grid, and it's going to give me the best one, right? And of course, you can see my CV to 5 is going to do some cross validation about 5 times. So it's a lot of things that is happening in the background, just that I can get a better result, or just that I can ensure that my model is not overfitting, which is also some of the cool thing you can look at. And again, you can see how I'm also using another method called randomized search CV, which is an opposite, which is another one. If I don't use the click search CV pipeline, I can use this randomized search CV too, just to show you, as it were, from what we have tried. So this might take some time. And please, like I mentioned, the material I sent to you, um that PDF, almost attempting all machine learning problem. Please look at it carefully, because there are some concepts that we don't have time to look at. For example, from the material, you will see how to do assembling, bagging and boosting, voting classifier, and all of that. Different models are tried, in that material. I would advise that you find out time to go through it, try the exercises there. It keeps you to become strong. I think this is done now. Okay, good. So you can see the best parameter he gave me. That means these are the guys I can use in my model. So these are the ones he used. The best estimator now, based on the result of the model, is bootstrap to be false, max depth. So let's use this guy now, in our model alone. Instead of using all these guys, we can now come here and do something like this. Let's just copy this. So I can see how, after it has done the estimation, how do I use it. So I'll change it. Random forest classifier, max depth. It says here the best one is what is 10. Change that to 10. Number of estimator, it says 200. I will use that. Bootstrap to be false. I will add this. Now, the fact that he did that doesn't mean that the result is also going to be better. But you have to experiment it. What if it works well? Meaning leave should be 1. I'll just try all these guys and see if my model is going to improve. Mini split 2, estimator, maximum leave. I didn't think he's using anything like that. So I will comment this out. So let me see how this model is going to do. Maximum feature, is that anything like that was used? No. I'll comment this out. So I'll use this guy. Let's see how our model is going to do. Look at that. You have 82%. What was the result here? 82%. Even when we did not do a parameter tuning, you can see the result. So you need to keep trying. Let me add these ones that they placed here and see what my result will be. So almost same 82. Let me try for the randomized search and let me get some value. So the point is that you did grid search or you got some hyperparameter tuning. It does not necessarily mean that it's going to be performed better, but at least you have tried something, right? You have experimented something, all right? So those are some of the things you need to leverage on. So it doesn't mean that it's going to automatically always perform well. It's all about the data. We've split it into four portions. Oh. If you look at the top, we split that into four portions. Okay. So somebody is asking, at what percentage should correlation feature be considered for possible overfitting? Sincerely yours, at this stage, we might not necessarily be able to say a particular percentage, but the expert can tell you, oh, this feature, you don't need it. The expert will be able to do a good job there. Domain knowledge will be able to help you there to know it's not even about percentage, it's about should I use it at all right? Like I told you, I was working on an HIV tax with a company in Congo, right? I was using a particular feature to predict. Of course, I was getting results, but the guy asked them, no, with that feature already, we know if somebody has HIV or not. So at times, the idea of features selection or removal has a lot to do about domain knowledge because you don't just wake up and say you want to remove something. What is the justification for it? But then correlation also can be a pointer. This guy is too big, maybe 60-70%. But domain knowledge, your line manager will be able to guide you. People who understand what those features are and how important they are to the model you're trying to build, right? So, for example, if you're trying to predict somebody is going to pass an exam or not, imagine you are now using the jam score in your prediction. Obviously, by that jam score alone, it's going to just tell the person is going to pass. Because if you want to predict somebody's jam score, you don't need to pass the jam score into the result again now. So by the jam score of the person, you already know the person has passed. Do you get that? But those ones should not be in the features, right? They should not be in the features you're trying to use to train the model. I hope that is clear. Okay. So let's look at that one that we're trying to. Okay. The only result is giving us is the n estimator. So let's see if there's any improvement from this. So somebody's asking about the support and all of that they are seeing. They are not really a concern at this point. They're just part of the values that you get in your classification reports. Yeah, those stresses, of course, you can always read about them, but they are not as critical as the metrics that we are so much familiar with. So these are some of the things you can do. These are some of the things that you might also want to try out. The things we are not able to cover here, which I want you to take note, is how do we handle imbalanced classes? How do we do combination of more than one models to improve our model performance? Those are some of the things that we are not able to cover at this time because of the things we want to also look into, even in all that we are doing. So, any other question? Any other question? So, we go on our break, and when we return from the break, we will just do some other recap. Then I'll push in some problems, challenges that you can try over the weekend. So let's go on our break and go back. So it's 8:10, 8 already, so we come back 8:10. Okay, so welcome back, everyone. So, just like I mentioned, my advice for everyone, please critically look at some of these things. I know that you might be hearing some of these things like for the first time. I understand that some of this technicality still needs to be well properly checked. Please find out time to go through this. That's why I'm going to end here. And with this, we are gradually coming to the end of our machine learning class because there are still a few things we need to touch. We have just, you know, say 1 or 2 weeks to go, right? And I want to briefly touch NLP on Monday, while Tuesday and Wednesday next week will be used for GitHub setup with Ezekiel. And the last week will be for revision and a little bit of prompt engineering so that we can just, the goal is that we can touch some of these things, know what they are, then in your long-term goals you can build on them. All right, so there are a few things I want to share now, and I will advise that you go through them. The beauty of a class is that you are able to work on projects, you are able to get your hands dirty, all right, as it were. So like I mentioned, okay, let me change the screen that I'm sharing. Okay, so let me know when you can see the approaching any machine learning problem. Are you able to see that? Okay, so you're able to see that. So what I wanted to show here is this material, even when I started to, was so handy. And trust me, something that if you sit down, you can finish in a look. But then it's advisable that you code anything that is there. All right, it has modules, and of course many of the things that are here we have done them. You just need to also, follow another thing. So almost what is here now, if you look at this now, all these things here we've talked about them to this stage, which is okay at your stage. All right, but you should still read about it. So I think I've covered almost everything that I highlighted, which shows that you have good knowledge base, for you to build a successful machine learning model. At least if in I mean, this is a whole lot really for me. If in 2 weeks or 3 weeks thereabout, we have been able to cover 5 to 155 pages of a 300 book, right? That shows we have been able to cover a good level of concepts, right? And kudos to the team who has made this happen, and kudos to you guys. I mean, that's a whole lot. But then you can look at this in more, at least you have an idea of what it is, but now you can look at it from more other perspective, right? So please, our advice, we have done almost everything here, at least, you know. Uh, then, like I said, the part I wanted to check is this part, this assembling. Then, like I said, on Monday, we'll talk a bit about NLP. All right, then you'll be able fit for this. We are not able to talk about computer vision at this class, but then with the knowledge that you have gathered here, you can always do that, at your end. Now, I'm going to be sending 2 files to the group or on the LMS. It is a project I wanted to try out in this week, and it's about a company called Yakub Training Group. It has all the information that you need. It gives you an idea of what is available in the data set, that you can also try. All right. I'm going to drop that in the group. Please look at it critically. The goal is to build the machine learning model. So based on what you have learned, in whatever it is that you are submitting, I'm expecting you to do all your data cleaning. I'm expecting you to generate insight. And please, like I've said, when you generate insight, explain your insight too. Don't just draw. If, for example, you plotted something, interpret it. All right. Interpret is very, 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 very important. You have to interpret whatever it is you have in your results, your preprocessing, explain them. What you're trying to do is very key. Do your encoding when necessary, do your feature selection, do your feature engineering, do your splitting, build your model, try as many models that you can. This is a classification problem, yeah. So do your classification report, get your confusion metrics, as many things that we have learned in the class really that you can leverage on, try them out. It's going to be useful, it's going to be handy for you, so I'm going to send this once the class is over. I'm going to send this to the group. Okay. So that, I think, let's start with this. Of course, I'm still going to send some certain other ones, even the coming weeks, that you can try out. Yeah. So that was what I was going to say. So let me look at it if there's anything else before we call it a day tonight. Yeah, it's individually. Yeah, it's an individual mini project. It's an individual mini project. Trust me, there are things you can always do yourself. You don't, of course, if you need help, why not? You can always ask for help. Um, of course, I'm not sure it is going to be easier to do a group project because in this class alone, you have more than 500 people. So I'm not sure that is possible. So it's going to be an individual project. Yeah, so something I wanted to show. Yeah, I just remembered. When you are sending whatever it is that you have done, you're going to be sending me your notebook in HTML format. All right. Yeah, in HTML format so that it will be easier for us. So if you come to your file, for example, you will see exports, whether you are using Jupyter Notebook or Jupyter Lab, you will see save and export as HTML, right? So click on this HTML, it's going to download on your system. And of course, the file should be saved with your name. The file should be saved with your name. So you can see it has downloaded and now is opening it. So it has downloaded for me. So this one, I don't need anything. Let me show you what I'm saying. So now I've downloaded the HTML. So I don't need any kernel to be running for me to see your code. Of course, you still submit the IP1 MB file, but at least with this one, I can see what you've done. I can see everything you have done, your input, your output. I can see everything without having to run. This is always easy for anyone to submit. So please, you are going to submit an HTML file and also a IP IBYMB file. The reason why you're submitting HTML is because so that I can click on it anywhere, even on the phone, I can see what you've done. Okay, so a Google Drive will be available for submission on Monday. Don't ask me till Monday. I've already said Monday now. Nobody should ask me why I was submitting. Whatever you have done till Monday, on Monday I will release the Google Drive for you. All right, to work. And please work on your model. Try to ensure that they are not overfitting. Try to ensure that you are doing your very best. Do research. Don't just depend on all you have learned in class. Yes, what you have learned in class is good start, is good enough, but there are many other things that time does not permit us to even look at. All right, so you have to make your research. There are many notebooks, many articles on the internet that you can also leverage on. All right. So I think those are the things to talk about at this time. But with what you've learned, you have a very good knowledge of all it takes to deliver, your project. Please come again, the HTML. So to use the HTML, you need to click on your file. Let's say this is the file you want to convert. You will see save and export notebook as. So you have many options there. So you click on HTML. So it's going to download on your local system, and that's the format. So the HTML and the IPYNB file is what you are going to need for the project. Yeah, we are moving and it's getting better, it's getting deeper. So my advice at this point, you need to ensure that you understand what we are doing. And the only way to understand what we are doing, one is go back to your notebooks, you have access to them. Make sure that you run them. Look at the line of code line by line. Try to explain what it means to yourself. To yourself. What are they doing in this line? If you don't know it, ask your LLM system. Explain this line to me as a dummy, as a beginner, as a fresher. So it's going to explain to you. So the goal is that at this stage, you should not be seeing any machine learning model notebook, any analysis project notebook, any Python notebook, and you should not understand what it's saying. No matter the level that it is, by now, when you see what, oh, this is the function, oh yeah, this is, they're trying to import a library, oh yeah, they're trying to do this. By now, you should have those level of knowledge. All right, you should have those level. If you know that right now you don't, please go back to the beginning. You have all the time to yourself. All right, you have enough time to yourself to go through some of these things. And of course, you're going to be doing a quiz for your final exam. Is purely machine learning questions. It's purely machine learning questions. It's going to test the deep things about what I've said. All right, they are basic questions, but it needs critical knowledge to answer them. Like I said, I don't know how to set questions, but then the goal is that you look at the questions critically. All the things we have said in the class, it won't be outside what you have learned in the class, what I've said in the class, what I've asked you to read in the class. So it can't be outside those things. So I think it's going to be like 20 thereabout questions. And please, any quiz you are seeing, even whether you should try them out too, because that's the only thing that confirms that you know what we are saying. All right. How many models, as many models that you want to build, you are the is your project. You only darasi. Apparently, people that does not hear Yoruba, so you can dara to it. Okay, so as many models that you want to, you want to do. There is no group work for now. I've told you you have 500 people in this class. So how do we do group there? But if you have any question, you can always ask in the group. You can always ask in the LMS. All right, somebody will be there to answer your question. All right, of course, you can reach out to your colleague. Nobody's stopping you from doing that. But my point is, as much as you can, try and do something. All right, try and do something. Okay, if you have question, you have between from today till Monday to try it out. But it's risky not to try these problems out. I'm going to make it two different problems so that you can try something out. But you don't have time is not an excuse. So we don't have light, it's not an excuse. So we don't have data, it's not an excuse. So I'll be busy at work, it's not an excuse. So growth needs efforts. All right. I know you have enough reasons. Like I used to tell my learners, all your excuse, I know them. I have no problem with them. They are correct. You are good. No light, Abi, no data. Work ethic. I understand. Well, there are no excuse. You need to find out time. As busy as you are eating, right? For many of us who are married, we have time for our loved ones. For many of us who has is it fiancé now or fiance, you create time in your busy schedule as you are leaving work around that 7 p.m. You are still trying to say, darling, can we meet at so restaurant? Can we hang out? So whatever you love, your mind is there, no matter how busy that you are, right? So please, let's see it from that perspective. If you love improving your technical skills, if you love trying new things, please, I will encourage that you try this out. All right, that's going to be my uncle's advice, if there's anything like that, or children's advice. Imagine somebody is already asking me if I did not finish before Monday. You can finish next year. You can finish next month. You can finish anytime you want. We are saying no excuse. Now somebody is already posting. There are comedians in this call. I'm saying no excuse, and you're telling me if you did not finish on Monday, finish on Tuesday or Wednesday or next week Monday. You know. So I mean that's on a lighter note, but I mean try something out. There, nobody obviously is going to finish because there are always something new that you can try. There's only something else you can try, as it were. So you need to just put efforts. At least by Monday, have something to show. Don't come and say, I mean, like I said, I'm used to hearing an excuse, right? So I'm used to hearing an excuse. Somebody saying is a SST student. I'm currently writing my exam and I also go to lessons. It's okay. Pay attention to what is, pay attention to what is most important in your life right now. It's all fine. And you can always come back to this. The problem is still the problem, whether you come back in the next 1 month or you come back in the next 3 years, you come back in the next 5 years. The problem is still the problem. The process to solve it is still the same process. So nothing has really changed. So take your time, take as many time that you want to yourself. That's my biggest advice. If you have exams, other priority thing, this is cleaning up. All right. Okay, so any other question, don't worry, you can keep it up so that by 8:30 we are out of this place so that you can go and rest. I know you've had a long day like myself. Uh, Trust me that I've had that. I've been training for almost a decade. So I've had a number of things. Right? You don't have a laptop, you don't have, I've had them, but like I used to say, so I'm used to that. I will only say okay because your excuse is as genuine as whatever it is that you have said. You are not lying. But I mean, you just need to find some time, to try things out. Okay. So thank you everyone for joining. Look at in the chat in the LMS platform for the questions and try them out. Pick them up. Take your time. It's not difficult. If it's difficult, I won't be here, right? So I don't like what is difficult. So you can also see it from that perspective. Okay, so see you again on Monday. Of course, we still be on our LMS on the WhatsApp trying to guide ourselves. So good night, everyone.